Hi everyone. In today's lecture I will talk about Golang, and in that I will talk about arrays and slices. So let's talk about arrays first. An array is a collection of elements of the same type. Mixing of types in an array is not allowed in Go language. So that means that you cannot have integer or float elements in the same array. An array can only be of one type. An array can be a collection of integers, floats, or strings, but etc. But mixing of types is not allowed in the array. So you cannot have integer, floats, or strings in the same array. You can only have one type in each array. Array declaration. An array belongs to type nt. N is the number of elements in the array, and t is the type of the elements. So in this you can see the program, and inside the main function you have a variable array a of size 3 and type integer, and it is then printing that particular array. So let's have a look at this program in the playground. Okay, so here you can see that you're importing a package called FMT. FMT is a package that can be used to manipulate output and inputs. So here you have declared an array inside the main program, and then you're printing the array. By default, the values of the array will be zeros. So if you run this program here, you can see that as you have not declared any values inside the array, the default values will be 0. If you can change the size of the array here, you can make it 5 for instance, and then you can run this, and then you can see that there will be 5 zeros printed in the output. So if you have not initialized any values in the array, then by default the values of the array will be zeros. Now let's start assign values to the array. So let's assign some values to the array in the previous example. The index of the array starts from 0 and ends at length minus 1. So here inside the main function we have the same array a of size 3, and after that we have initialized it with values. With a0 is 12, a1 is 78, and a2 is 50, and then we are printing the array. So you can see here that the index of the array starts from 0, that is always from 0, and ends at length minus 1. So the length of the array is 3, so it will end at 2. Now let's run this in the playground and have a look at the output. So let's run this program, and here you can see that the output here is 12, 78, and 50. That are the values that we have initialized in the array. So now that we have seen the values that we can assign to the array, we can have a look at a shorthand declaration as well. So let's create the same array using shorthand declaration. So here you can see that inside the main function we have array a of size 3 of type integer, and then we have a shorthand declaration that we have assigning values in the same line as 12, 78, and 50, as you can see. After that we are printing the array. So let's run this in the playground, and let's run this. So again you can see here that the values are 12, 17, and 50 in the output. So this is the shortened declaration that you can use to assign values to the array, and you can do this in the same line of declaration as well. It is not necessary that all elements are assigned values in shortened declaration. By default the value will be 0. So here you can see that inside the main function we have a array of size 3, and we have only mentioned one value 12. So at the index 0 of the array the assigned value is 12, and the remaining two values will be 0. So if you run this in the playground, and then we can see here that at index 0 the value is 12, and the remaining indices the values are by default 0. You can even ignore the length of the array as well in the declaration, and replace it with the two dot three dots, the compiler will find the length for you. So here we have declared the array A, and we have not mentioned the length here. We have mentioned three dots and then integer 12, 78, and 50. This is the shortened declaration as well, and then we can printing the array as well. So now run this in the playground and we have a look at the output here. So if you run this, you can also see here that the values are 12, 78, and 50. So you haven't mentioned the length here, you have only mentioned three dots here. So by default, the compiler will find the length for you. The size of the array is so that means that you cannot assign different size arrays to each other. So in the main program, you can see here that A is the array 3 of size 3 with values 5, 7, 8, and 8. And then we have another array of B of size 5 type integer, and then we are doing B equals to A. So B equals to A is not allowed in this particular case because size of A and B is not the same. So if we run this in the playground, it will give you an error. So as you can see, the error is cannot use a variable of length of type 3 as type 5 value in the assignment. So that means that the different size arrays cannot be equated or assigned to each other. Arrays are value types. So that means that arrays in Go can be made changes to the arrays in the array, but that change will not be affected in the original array. So that means that if you make a change in the array or assign a new variable and make changes to that particular variable in the array, then that change will not be uh, reflected in the original array. So as you can see here that A is a array of type string, and then we are equating B equals to A, so we are assigning A to B, and then we are changing B index 0 to Singapore, and then we are printing A and then we are printing B. So that means that if we print these values of array A and print values of array B, A will not be affected by the change we made to the 0 index of B because the copy is made as a value and not by reference. So if you copy by value, then that means the original array will not be affected if the change is made to the copy. So if you run this in the playground, then you can see here that A is USA, China, India, Germany, France, and B is Singapore, China, India, Germany, France. So that means only B is affected, and the change that we made to 0 index of B was not reflected in array A. So that means that in arrays, uh, arrays are value types and not reference types. That means that if we assign array to a new variable, changes are made to that variable that will not affect the original array. Similarly, when the arrays are passed as parameters to a function, they are passed as values. So if you can pass the array to a function, then if it made changes inside that function to that array, then that change will not affect the original array that we have passed. So here we have a function called change local that takes an array of size 5 and type integer. And inside that change local function, we are changing the index of the array 0 to 55, and then we are printing the array. Inside the main function, we have the array num of size 5, and it is declared as 5, 6, 7, 8, 8. And then we are printing the array num. Then we are calling the change local function to make the change to the 0th index of the array, and then we are printing the num again to see if that change is affected inside the original array or not. So let's run this in the playground and have a look at the output. So if you run this, you can see that before passing to the function, the values are 5, 6, 7, 8, 8. That are the values that we initialize initially. And inside the function, the values are 55, 6, 7, 8, 8. So inside the function, we have changed the 0th index of the local array num and we have made it 55, and then we're printing the array. So inside the function, the value will be changed because we are assigning the value to the index of 0 to, but after passing to the function, the value remains the same. So when you come outside this function, the original array is not affected because the array are passed by value and not by reference. So now let's talk about the length of the array. Find the length of the array. The length of an array can be found by passing the array to the function length or len. So in the main function, you can see that a is defined as a float type array and takes 1, 2, 3, 4 values. And then we are printing the length of the array as length of a is the lena inside the println function. And if you run this, you can have a look at the length as 4. So the length of a is 4 because there are 4 elements inside the array. If you can add one more element here, let's say 80, then if you run this, then the length will be 5 here because now we have 5 elements inside the array. So you can actually change it again to, let's say, add one more element here, 79, and then you can run this as, and then you can see the length is 6. You can also remove 2 elements here, or 3 elements here, and you can run this again and have a look at the value of length. That is 3 because there are 3 elements inside the array now. So this is how you can obtain the length of the creating using for loop. So the arrays can be iterated by using a for loop. So if you can have a look at the main function here, you can have an array A of type float that has 4 values, and then you have a for loop which index I equals to 0, I less than length of A, and I plus plus, and then you are printing the values of the index and the value at the index. So we are using printf here. Printf is used to format the output of uh, that you're trying to output basically. So you can use %d means that it is a decimal value, and %.2f means that it is a float value of 2 decimal places. So you can see here that the index I goes from 0 to length a, that is length minus 1, and the value and index are printed here. So if you run this in the playground, you can have a look at the output. So if you run this, you can see that 0th element of A is 67.70, 1st element of A is 89.80, 2th element of A is 21.00, and 3rd element of A is 78.00. So this is how you can actually output the values of the array using a for loop. Iterating using a range. So range is also one more keyword that you can use to actually find the index and the value at that index in the array. So inside the main function you have an array A of type float that has the same values again, like the previous example. And then you have another variable called sum that is also type float, which is initialized to 0. And then you are using a for loop with iv equals to range a. So range a will return the index in the I variable and the value in the v variable. And then you have the format printf %d, the element of a is %.2f slash n iv, and then you are doing sum plus equals v. So this will actually print the value of the index and the value at that index, and then it will compute the sum of all the values inside the array. So sum plus v basically means that each element of, of array A will be added to the previous element of the array. So initially sum is 0, so it will be sum 0 will be added to 67.7, and then 67.77 will be added to 89.8 in the next iteration, and then in the next iteration the the sum of these two numbers will be added to 21, and then in the next iteration all these three elements sum will be added to 78, and then you have the final sum value printed at the end of the for loop. So if we run this in the playground, you can see that it is printing all the values of the array first, and then it is computing the sum of the elements as well, which is 256.5. So this is how you can actually find the sum of all elements inside the array using a range variable and a for loop. We can also have multi-dimensional arrays as well. That means that you can have 2 by 2 arrays, 3 by 2 arrays, 3 by 3 arrays, 4 by 4 arrays, etc. So if we can run this in the playground to have a look at the code. So you can see here that we have a function print array which is taking a multi-dimensional array of size 3 2 of type string, and then it is printing that particular array in using two for loops. So this underscore here that you can see is meaning that the index is optional. So here we are not interested in the index value, we are only interested in the value at that index inside the array. So range returns v1 array, and then v1 array returns the value v2, and then the value v2 is printed, and then you can see the output in the end. Inside the main function you have the array a of type of size 3 2 and type string, and then it is initialized as lion, tiger, cat, dog, pigeon, peacock. And as you can see here that at the end of this uh, third combination of pigeon, peacock, we have a comma. So this comma is essential because the compiler will complain if you omit this comma. So you have to add this comma at the end here. And then you're printing this particular array, and then you have another array called b of size 3 2 type string, and then you are also initializing it as 00 Apple, 01 Samsung, 10 Microsoft, 11 Google, 20 AT&T, 21 T-Mobile, and then you are printing this particular array as well using the print b function, uh, print array function. So if you run this, you, you can see here that all two arrays are printed. First array A is printed, and then array B is printed. So this is how you can have actually define multidimensional arrays in the Go language. So this actually wraps up our array section of this particular lecture, and now let's talk about slices. So slices are just references to existing arrays. A slice with elements of type T is represented by square brackets and then the type T. So you can see here inside the code that the function main has array A of size 5 and type integer, and it has 5 values: 76, 77, 78, 79, and 80. And then you have a type variable B of type integer. This is a slice, and this slice starts from A index 1 to length of slice minus 1. So that means that slice B will take values from array A that will start from index 1 of array A and end at 4 minus 1, which is the length of the slice, which will be 3. So that means that if we start looking at the value at 0th index we have 76, at 1 index we have 77, at 2 index we have 78, at 3 index we have 79, and at 4 index we have 80. So we are taking values from the first index of array A till 4 minus 1, that is 3, up till 3 index. So 77, 78, and 79 will be the values inside the slice B. So if you run this in the playground, you can have a look at the output, and you can see that these are the values 77, 78, and 79 that are inside the slice B. So this slice B is a reference to the original array. So that means that if we make any change to this slice B, that change will be affected in the array as well. It is not like arrays that we can make changes to it, because in arrays we do it by value, but in slices we do it by reference. So let's look at another way to create a slice. So one more way to look at how we can create a slice is by this square brackets and type and then 678. So if we define it like this inside the main function, then this creates an array and returns the slice reference to the array. And then we can print this particular slice as well. So let's run this in the playground and see. So it prints 678. So 678 is the slice value, and that is the reference to the array 678. Modifying a slice. So slice is just a representation of the underlying array. Any changes to the slice will be reflected in the array. So if we make any changes to the slice, that change will be affecting the array as well, which is the underlying array. So if we look at the main function, we have d array, which is of size 1, 2, 3, 4, 5, 6, 7, 8, 9, and it takes integer values. And then we have a slice, d slice, that is the slice in the d array, which is from index 2 of the d array till index 4 of the d array, which is 5 minus 1, 4. So if we print this array before making any changes to the slice, then you can print it here first, and then you can make a change to the slice by using a for loop. So for I equals range d slice, so here we are returning the index in the for loop, and then we are changing the value at that index of the slice by incrementing it by 1 inside the for loop. And then we are printing the array after this for loop as well, so have a look at whether the changes to the slice has affected the array or not. So inside the for loop, the values at index 2, 4, 2, 3, and 4 will be changed, because this is the index of the slice, and then they are incremented by 1. So that means that at index 2 we have 90, so 90 will becomes 91, and then 82 becomes 83, and 100 becomes 101. So if you print this after the for loop, then you can see that this change will be resulting in the D array. So let's run this. So array before is the actual array that we have declared, and then after array is that it becomes 91, 83, 101. So the changes are made to index 2, index 3, and index 4 of the array, because we are changing those indices values of the slice inside the for loop, as we have discussed previously. So so here we have seen that modifying a slice actually modifies the array as well. So if more than one slice shares the same array, then modifying each slice will result the change in the reflect in the array as well. So if we modify slice 1, which share the array, and then slice 2 that shares the same array, then both changes will be uh, uh, reflected in the array as well. So here you can see the main function. We have num array of size 3 and type integer with 78, 79, and 80 as values, and we have nums1, a slice to the array A that has all the values of num A, and then num2, which has another slice which takes all the values of num A as well. And then we are printing the array before changes to num A, and then we are making a change to num1 0 as index, making it 100, and then num2 1, making it 101. So slice 1 is changing the array 0 index to 100, and slice 2 is changing the 1th index of the array to 101. So if you print these values, you can see that these two changes will be affecting the array as well. So let's run this in the playground and have a look. So array before change 1 is 78, 79, and 80, and after modification to slice 1, it is 100, 79, 80, and modification of slice 2, it is 100, 101, and 80. So both the changes are actually retained in the array A, which is the original array. So this actually shows that if more than one slice shares the same array, then changes to each slice will be reflecting in the array as well. Length and capacity of the slice. So the length of the slice is the number of elements in the slice, and the capacity of the slice is the number of elements in the underlying array, starting from the index from which the slice is created. This is important. So the capacity is not the entire length of the array, but it starts from the index from which the slice is actually created. So let's have a look at the main function. We have a fruit array which is of type string, and it has 1, 2, 3, 4, 5, 6, 7 values. And then we have a fruit slice, that is a slice to the fruit array, which starts from index 1 of the fruit array and adds at index 2, which is 3 minus 1. So that means that inside the slice we have elements orange and grape. And we are printing the length of the slice and capacity of the slice as well. So let's have a look at these values first. So if you run this, you can see that the length of the slice will be 3, not 3, 2, because that is 3 minus 1, 2. So the length of the slice will be 2, and the capacity will be 6, because we are ignoring 0th index of the fruit array, and the capacity starts from the index of the slice. So slice index is 1. So we start from orange, not apple. So from orange we have the length is 6. So the capacity is 6. So if you run this, you can have a look at the values. Length of slice is 2 and capacity is 6. So I hope this explains how length and capacity works. Next is that a slice can be resliced up to its capacity. So that means that a slice can be resliced again to its capacity, up to its capacity. Anything beyond that and the program will throw runtime errors. So a slice cannot be resliced beyond its capacity. So if we have a look at the main function, we have the same fruit array and then the fruit slice, and then we are printing the values of slice length and capacity of a fruit slice, and then you are reslicing the fruit slice up to its capacity. So we have fruit slice equals to fruit slice, all elements fruit slice till capacity of fruit slice. So reslicing fruit slice till its capacity, and then we are printing it again, the slice length and the capacity of the fruit slice. So the first printf will actually print the length as 2 and the capacity as 6, and the second printf will print the length as 6 and the capacity as 6 as well. The length is 6 because all elements of the fruit slice till capacity of the slice will be the length 6, and then capacity is again 6. So if we run this in the playground, you can have a look at the values here. So the length of slice to capacity 6 is the first printf, and then the second printf is that after reslicing the length is 6 and the capacity is 6. So this actually explains that how you can actually reslice the original slice up to its capacity. Now let's look at a slice using a make function. So we can also make a slice using the make function. So the make function is that make takes three elements, three attributes. The first one is the type, the second is the length, and the third one is the capacity. The third element is actually the capacity attribute is actually optional. So you can actually ignore capacity and only pass type and length of the slice, and it will create the slice for you. So inside the main function we have the iSlice, which is make, and then it takes type 5, uh, type integer, length and capacity is 5 5, and then it prints the slice. So since we have not declared any values to the slice, the by default values will be zeros, so it will print five zeros. So if you run this in the playground, you can have a look at the output. You can see that if you run this, it prints five zeros, which is the length of the slice. If we initialize it to values, then those values will be reflected in the output, not zeros. So this is how you can make a slice using the make function. Then appending to a slice. Whereas arrays are restricted to fixed length, the slices are dynamic and the length can be increased by using the append function. So you can using the append function, you can actually increase the length of the slice by adding values to the slice. So you can have a look at the main function here. You can have a car slice which is of type string and takes three values: Ferrari, Honda, and Ford. And now you're printing this particular car's length and capacity. Then you're appending a value to the cars by adding Toyota to this particular car slice, or using the append function. And you're again printing the length and capacity of the car's slice. So by appending a value to the slice, you can actually increasing the capacity by twice its size. So if the previous size is actually 3 of the slice, then the new capacity will become 6 after appending to the slice. So if you run this in the playground, you can have a look. If you run this, you can see that initially the cars Ferrari, Honda, Ford slice has length 3 and capacity 3, which is how it is. But after appending the value to the car's slice, the length becomes 4 and the capacity becomes 6. So now let's have a look at what's next in the topic. It is possible to append values to a nil slice using the append function. So if the slice has no value at all, you can actually append values to it by adding values to it by. So inside the main function, we have a variable name string, which is a string slice that has no value inside it. That is, it has a nil value. And then you have a if condition that states that if names equal null, and then it says that println slice is nil going to append, so it is going to append now to values. So names added three values: John, Sebastian, and Vinay, using the append function. And then if you println again, then you can see the names has three values: John, Sebastian, and Vinay. So if you run this, you can have a look that slice is nil going to append, so the name content is John, Sebastian, Vinay. So after appending the values to the names function and printing, you can see that the names slice will have three string values. You can add one more value to it as well. Have a look here, and you can add David, for instance. And if you run this, you can see that the name content have four values now: John, Sebastian, Vinny, and David. You can keep on doing this as long as you want. It is also possible to append one slice to another using the uh, epsilon operator or the three dots operator. So inside the main function, we have the veggies slice, that is string type, and takes three values: potatoes, tomatoes, and brinjal. And then you have one more slice called fruits that takes values oranges and apples. And then you're appending veggies and fruits together. So you're appending fruits to veggies and making another slice called food and then printing that particular slice. So if you run this in the playground, you can have a look at the output, and you can see that the food now has five values: potatoes, tomatoes, brinjal, oranges, and apples that are appended to each other in inside that program. So this is how we can actually append slices to each other using the epsilon operator. Passing a slice to a function. So slices can be passed to a function as arrays, but the important point here is that the passing is done through reference and not value. So that means that any change to the slice inside the function will affect the underlying array. So here you can see that the function subtract one, it takes a slice called integer of type integer, and then it subtracts 2 from each element of that particular slice inside the for loop. So inside the main function, we have the numbers slice of type integer, that is 876, and then you're printing this particular slice, and then you're calling the function numbers and passing it numbers, and then you have printing it again once more. So any change inside the function will be reflected inside the array as well. So that means that if you print again numbers at the end of subtract 1 call, then minus 2 will be 2 will be subtracted from each value of this particular slices element. So it will be 6, 5, and 4 at the output. So let's have a look at the output in the playground. And if you run this, you can see the slice before function call is 876 and after function call is 654 because it's passed as reference. So any change that we have made in the inside the function is also reflecting inside the slice as well. Okay, so this is how you can actually pass a slice to function and how it is modified. Then we have multi-dimensional slices as well. So similar to multi-dimensional arrays, we have also have multi-dimensional slices. So it is defined as inside the main function. You can see that there are two square brackets. The first square bracket and then the second combination of square brackets of type string, and then it has values inside this particular multi-dimensional array of C, C++, JavaScript, Go, and Rust. And then we are printing this particular slice similarly uh, to that uh, print function that we had in the arrays example. So if we run this in the playground, you can see that the output will be a multi-dimensional slice of values C, C++, JavaScript, Go, and Rust. So now let's move to our last slide, which is memory optimization in slices. So as we know that slices hold reference to the underlying array, as long as the slice is in the memory, the array cannot be garbage collected. So as long as there's a slice reference to the array and the slice is in the memory, we cannot garbage collect the array. One way to do this is actually copying that particular slice into another slice, and then the array can be garbage collected. So if you can see in the uh, program, we have a function called countries, and inside the countries we have a array called countries that is of type string and takes 1, 2, 3, 4, 5 values. And then we have needed country, which is a slice to the countries array, and that goes from all the values in the countries up till length minus 2 of the countries array. So that means that the last two elements of the countries array are not in the slice. So India and Australia are not in the slice. Only USA, Singapore, and Germany are inside the needed countries slice. And then we are having a countries copy slice, that is make string of length needed country. So if we are using the make function to have a copy of the slice, create a copy of the countries slice, and then we are making it
making its length as the needed country slice. So that means that the length will be 3. So then we are using the copy function and copying the needed countries inside the countries copy and then returning the countries copy slice. So we have so like this we are actually copying the slice reference to the array to another slice and returning that particular slice inside the function. And then we have the main function in which the countries needed, which is calling the countries function. And the countries needed is a copy of the countries that we have received from the function countries. And then we are printing this particular countries needed slice. So let's have a look at this particular output. So you can see here that then in the output, it should be USA, Singapore, and Germany. So as you can see here, it is uh, USA, Singapore, and Germany. So this is how you can actually copy a slice to another slice and then print it while the original array can be garbage collected. So this actually wraps up our arrays and slices lecture. And I thank you very much for your combination, for your participation and contribution.